Okay, so so just a little bit of background on this panel before we get started. The basic idea was that feature stores came out. If we take the starting point as Michelangelo, they introduced the concept of a feature store around what I would call a domain-specific language. It's a well-known concept. So it's not a general purpose programming language, but it's a way of defining features in some syntax that you develop. And then it compiles into some code which is executed. Now, in many feature stores, that might be Spark or it might be SQL to run on some data warehouse. And it was often done with big data in mind. So we've heard this morning, handling terabytes of data, doing complicated point-in-time joins with massive amounts of data, putting handrails on data scientists to make sure that they don't shoot themselves in the feet. There's obviously a huge need for ensuring that features are correct, and DSLs can obviously contribute to that. But we've also seen with the likes of Hopsworks and Feather and other feature stores, more general purpose programming approaches. So using Spark and Python in particular, and DataFrame based APIs, we can call them. So imperative APIs, where a feature store stores data frames, you write data frames, you read data frames. But then the third aspect are the non-functional aspect of your APIs. So if you a feature store that has an operational aspect, so it has to return features within a certain latency, and it has to create training data within a reasonable amount of time. They also play into the role of the feature store. So I'm going to start, and I'll ask a question in general for everyone. What is the role of domain-specific APIs? Is that the future of feature stores? Is it the past? What's your opinion on domain-specific languages for defining features for feature stores? And we can take Amit. I'll go around in order, but we'll try and keep it brief. We have a few questions to go through. Amit, what's your take?
Yeah. So I think you brought up Michelangelo and DSL, so I can kind of speak for that. But I mean, I just wanted to clarify a little bit here, is that the way we think of feature engineering is like broken up into two parts, like the part that is done before data is ingested into the feature store, which is closer to data engineering, right? And that's the area where you can probably use anything, right? Like big data, SQL, we use SQL a lot before ingesting into the feature store. But the Michelangelo sort of system applies DSL post feature store retrieval. And the reason I think DSL plays a role there, and maybe Spark or any other technology, it's challenging to do so, is because our common deployment scenario is offline training, offline evaluation, real-time serving, right? So now imagine if you had used a Spark API and you use some sort of reduce operation, something crazy. Translating that to an online serving construct is extremely hard. And to do so in low latency, right? And so that is the reason we really implemented DSL to sort of contain the kind of transformations you can use, and it can be executed symmetrically online and offline, and keep the computation reasonable in the real-time world, right? So as long as you have any technology that can achieve that, I think it's okay. DSL is one way of doing it. That's my take. Yeah.
Okay, cool. So yeah, I mean, I think we agree on the model. You use the term model-specific transformation.
Yeah, like one-hot encoding and stuff.
Yeah,
like that.
So what a data scientist would call transformations, as opposed to what a data engineer would call transformations. I'll just go around in order. So David, do you want to give your take on this?
Sure. So I think this is a very interesting question. I think that I like to think about a Swiss Army knife analogy. I think that we want it to be easy for people to define features that they might be likely to say, pointing at the data assets that the company has. Like if someone wants to define a feature like the number of times a user has visited this part of the site over some range of time, and just to be able to use that as a feature, we want those things to be easy to say. And providing a kind of Swiss Army knife toolkit that makes the kinds of features, easy to say, that used to be more difficult when people would need to write their own data pipelines to do it, is sort of what we want to do. What belongs in the Swiss Army knife? Should there really be a Swiss Army knife, or should it actually just be like a big toolbox that's, like some bigger system like Spark? Like, I think that there are like a whole lot of things to say there. I think a lot of the things that Amit mentioned, about the challenge of trying to then do some online execution of code that was actually user wanted to write using a Spark API. You can't really do that kind of stuff. So there's different angles, to kind of go down with that. But what we do with Feather is we try to provide it is a Python API, but it is also kind of like constrained along certain rails to make it so that you can define features that can then be performantly produced. And then there are also, trapdoors to use like UDFs and other kinds of more advanced APIs for the cases where that is hard to do, or where the Swiss Army knife doesn't have exactly what you need. So at LinkedIn, we see some use of those kind of UDF APIs and things like that for advanced cases, but we want to hit it such that the Swiss Army knife covers, 80% of cases and still leave the more advanced stuff possible. There's probably even more I could say about like how these APIs should evolve in the future, but I'll probably pass to the next person.
Yeah, Xiaoyong, do you want to add anything on this on Feather?
Sure, I think that so first, this is definitely a good topic, and I want to bring up another perspective, which is from the feature consumer point of view. Because for feature store project to be successful, like within Uber, LinkedIn, Microsoft, or in many other customers, the first thing we want to do is that make sure that all the platform can be used easily, right? And then if they say, look, all the capabilities of this feature store is this DSL, and you need to learn the new DSLs to onboard to Feather or other feature store. And while in the meanwhile, the customers or the end users, they have already a bunch of code in Python, Spark, or whatever languages that they already have. It's really hard to migrate them to a feature store solution. And it's even harder to convince the LT because, feature store is more like a productivity tool. And then we are convincing them by saying, look, by using this productivity tool, you have to spend like half a year to onboard to this platform and, restructure all your feature engineering code. I think that's probably impossible to sort of convince the LTs and the management chains.
I think that's a very important point. Yeah, reuse of your existing feature pipelines. Yeah. Moritz, exactly. What's your take?
In general, I agree with what Xiaoyong just said. I also think that in the long run, the general purpose framework will win, because if you start with a DSL, you usually do it by providing a bunch of abstractions which limit, and then as you grow your use cases, you will want to onboard more and more complex aggregations or functionality. And at the end, you will end up with a framework which re-implements what was there, or your DSL gets more complex and more complex over time as you grow the use cases. And then you'll end up where you could have started off from the beginning.
I'll throw in there the example of testing, for example. So of course, everyone wants to test their feature logic to make sure it's correct. And, how do you do that in a DSL, I guess? Maybe that's not a question for you, Moritz.
No, but then my other point that I wanted to make is basically for streaming pipelines, maybe their DSLs have a chance, because the set of aggregations that you have and common operations, it's much more limited than in batch use cases. So that's what I see, that there's many more DSLs coming in stream applications.
Brian, you with Fabricate, you talked a bit about handrails for data scientists and helping them go off. What's your take on DSLs versus general purpose?
Yeah, so I echo a lot of the same sentiments as Amit, where there's like kind of two phases, the data engineering and the deployment side. And we use like a mixture of both DSLs and kind of general frameworks. And they've both been pretty popular with users, and general frameworks are great, but I think a lot of the success we've found is that General frameworks take a lot of boilerplate to interact with other components. And then so that constant copy pasting setup you need to do to interact or like start a new job kind of becomes tedious. And because you have so much copy pasted code, any kind of migration or API breaking change becomes a monolithic task, right? Where now all of a sudden you're replacing 1,000 references to really make a significant API change, or you're waiting for like a breaking component or a V2 function or something like that. And I think DSLs help you kind of avoid that situation. But I think in general, DSLs will naturally crop up for any general framework because not every company will have the exact same use case. And I think, yeah, even just how your data is structured and what you need will change from company to company. So you just end up needing a DSL, in which case, anyways.
So I'll ask a open question if anyone wants to take it. I mean, is there anything beyond DSLs and the kind of DataFrame APIs that we've seen out there? I've seen, for example, in data pipelines, there's some people looking at functional programming languages like Elixir for some of the benefits of functional programming for data pipelines. Are there any other approaches people can think about that maybe are interesting to look into?
Yeah, I mean, if you look at deep learning people, they are just using, there's no DSLs. They stop, they just retrieve features from the feature store in our case, and they just do the transformations inline in PyTorch or Keras. And so the whole feature engineering is now just part of the model ecosystem. So, which is what the scikit people did anyways in the beginning. But so it's kind of come back. I mean, so that's what we at least see. So there, so that's one form where, there's no DSLs, you just write code, and PyTorch and will restrict the amount of Python you can do anyways. Like I don't believe you can do like open-ended Python, but I think the key still remains, you need to restrict the type of computations you can perform so you can have some reasonable guarantees around at serving time, especially, right?
So, I mean, there's a good point in there, which is related to, sorry, Julian, you want to say something?
No, like a restricted data frame or something. Yeah.
A restricted data frame, like a snow park data frame.
Go ahead, Jim.
No. No, there's an interesting point there, which is related to deep learning. So feature stores are often associated with tabular data. Enterprise data is often tabular data. And, when we think about the APIs that we provide, they're often to help with the tabular use case. We have DataFrames to contain our features and so on. If you're using deep learning, you're probably not working with a pandas data frame. You're probably getting TF records or some other file format like that. So how expressive do our feature stores need to be, or do we just work on the enterprise use case for the moment? What are people's takes on this?
I can.
Okay, go ahead. I'll go next.
Yeah, I guess anecdotally to the first part of your question, I saw like a really interesting library today where Databricks just kind of open sourced Delta Lake, and one of the libraries they released is like Delta RS, which is a library to interact with Delta Lake written completely in Rust, but it cross compiles and has a library that publishes in like 5 or 6 different languages. And to me, I think the most valuable part of any feature store is the ability to interoperate with like 4 or 5 different services. And by necessity of a machine learning platform, most of these services end up being in a different language. Data scientists need Python, real-time needs Java, batch processing Java or like Scala, and then online services need to be in C++ or some low-level language. And I think one of the things we struggle with is having a common contract for how to evaluate a field or a protobuf or anything like that. And then so any kind of library that can abstract all these things away, where instead of writing the same function 5 times in different languages is kind of where we're going. And like just anecdotally from using like protobuf libraries from Google, this has just really simplified the handshake between everything, and having a single RPC server that manages all the interactions for how we manage and interact with features has really changed the game for us and lets us propagate changes out to the entire system almost instantaneously.
That's a very interesting point you make, Brian. It's when we think of APIs, we often think of them in terms of REST API with a specification in terms of the name of the method, the parameters, and the types. We also have data level APIs, what are often called data contracts. And when you obviously have many different clients written in different languages trying to interact with your feature store, there is obviously you have to translate that. If you're going to have an imperative endpoint, a network endpoint, you have to translate it for all of those different languages. Whereas if you use something like Arrow as a common kind of, data format that can be interpreted by all these languages, or protobuf or those, what are people's takes on the need for data contracts, if you will, at feature stores, or is that something that we're not there yet? Open question, anyone take it?
I can take that because I think as Brian just said, like it's probably more related to how you actually define a feature store in some way, because it's like feature store needs to be an open architecture because it needs to be operated with many of the other services. If we sort of fix it in a way that say, hey, everyone needs to use this fixed schema and fix everything, I don't think that will work to onboard feature store into many of the enterprise settings. And from that point of view, I feel that it should be like either protobuf or some sort of open standard or open schema for data, and then feature store will just adopt that rather than developing a new thing completely for feature store. That's sort of my high level take.
So feature store is a data platform and should live in the data ecosystem.
Right, that's my feeling.
Cool.
I think that you could also say that feature stores sort of imply their own kind of data contract just by what they need to do, right? What in the previous world before Feather was sort of unwritten contracts between training and offline experimentation systems and then the online systems that would need to run those models. It's kind of formalized with having names of, a feature namespace and feature types, and the ability to then use like a common serialization format or something like Arrow or whatever your system is going to use in order to actually present those features. It first requires having a registry and a namespace and a type system for the features.
All right, I'm gonna move to a little bit. So something that came up in both Amit and Brian's talks were embeddings, and where do they belong into feature store API? So I guess the bigger question is, should embeddings be part of feature stores? Should the feature store manage all data for AI, or should the embeddings live in their vector databases, or what's people's take on that? And maybe I'll put it Amit first.
Yeah. So I'll tell you our experience. I think a lot of embeddings you're seeing being built by the deep learning people. Traditionally, I think embeddings would be your first layers of your neural network, and that's essentially a very complex feature engineering that's going on inside the model. But I think people have been, at least a lot in the recommendation systems we've been working with, they're taking those embeddings and turning them into feature store like artifacts, right? And these are vectors of numbers. And so we are actually actively onboarding them to the feature store. So they're not, so you can sort of represent them and onboard them, not just in the feature store, but in Michelangelo as a whole, make them first-class citizens, right, of the platform. So this is a kind of like a form of transfer learning. You can actually optimize your models by taking your embeddings, persisting them in the feature store, and the feature store is then you just pick it up from the feature store into the downstream models, right? So that's what you're seeing a lot. And that's why we're kind of making embeddings. They're for first-class types, not just first line, but also embeddings need to be managed. Unlike a standard data pipeline, like an embedding is typically now these days generated through another deep learning model, right? So the life cycle of that model needs to be managed, which is slightly different than how you would manage a standard data pipeline, right? So that's how like the feature store design is getting influenced. Yeah.
I would just say +1 to that. It sounds very familiar with regards to how Feather is used within LinkedIn. We have many use cases that in their kind of model architecture, they will break the model, take the first layer that's producing embeddings, they'll run it as one model. The output is a feature that they put into the feature store to be able to use at serving time with a bunch of other models. Like it's a pattern that we see for sure. So that's like why we had to add tensor-based feature types and things like that in Feather. Yeah, +1.
Anyone else? Say anything on embeddings, Brian, Moritz?
I have a
Yeah.
just to answer your question, Jim. I think the conclusion there seems that, which I also agree, is that like everything, like feature store should support embeddings, but sounds like the embeddings should be stored in like a embedding specific system, let's say Milvus or those kind of embedding stores, while feature store should have more like the interface for that, like the embedding type support or vector type support, and then sort of make it first class citizen, as Amit just said. I think that's also what Feather is doing, and that's also what Uber is doing.
Yeah, I mean, so there's two parts to it, I think, which are interesting. One is that where should be the single source of truth for embeddings, because we do have vector databases, right? So feature stores do not provide similarity search, which is what embeddings are. One of the use cases for embeddings, that you have an embedding and you say, give me the 200 closest embeddings to this in this high dimensional space, and that's similarity search. And of course, you have specialized stores for that. But often those storage engines, they're more modern, more recent, and if we have, for example, OpenSearch in Hopsworks, and we can do embedding search or vector similarity search in that, and there's an API for it. But OpenSearch is not considered a single source of truth, right? You would store in one platform and then replicate to it. So I'm just curious as to, like, from a data scientist perspective, should we be providing a unified data for AI API to them to allow them to do all of these things, to do similarity search through our feature store APIs, or should we just have those as separate systems with separate concerns and just accept that, hey, data is becoming more and more specialized, so let each specialized system handle its own data? That's one of my takes on it. Any comments on that? Or
I mean, we try to make the feature store at least the source of truth as far as the definitions of embeddings are concerned. But we also integrate with our Uber's own search engine, which implements an ANN. So they're available for similarity search and other mechanisms.
So they're available
the
by
source of truth still remains valid.
Yeah, I would think about this like supporting different kinds of deployment targets. The feature store system should be able to, write to Redis for certain kinds of use cases, and then to be able to write into other kinds of retrieval engines, and where you're still the invariants are, you're still dealing with actually like the same feature, whether it is being served out through one kind of serving layer or if it's being served out through.
So maybe like we have offline, online, and potentially vector databases and another target.
Yes.
I have a question, because you brought this up, David, about embeddings being a feature type. So that's something I've spent a little bit of time thinking about. And in databases we have data types. So and we talked a bit about schema and unifying schema between online, offline, consumption, production, and some of the challenges of data flowing through systems and ensuring schema is consistent also across programming languages. So it's quite a complex topic. But in machine learning, we also have feature types. It's a categorical feature, it's a numerical feature, it's an embedding, it's a list. And they confer different capabilities. So, if it's a numerical feature, I might like to perform a form of what we call transformation. So maybe we're going to do a log transformation or normalize. And if it's a categorical feature, I might encode it into a numerical representation. Feature stores currently, as they are, don't really capture, I don't see any APIs that capture those feature types and enable to lift the level of abstraction of feature stores to make it easier to do that. Is there anyone who thinks about how we can help make it easier for data scientists or how we can extend our APIs to encapsulate some of those concepts that we talk about, but we don't tend to provide tooling for yet?
So we do provide something like this in Feather. There are kind of two notions of type, right? Like you, I think, mentioned. One is around kind of a semantic type of a data point that may matter to a data scientist, and another is more like what is going to be shape of this tensor when it is then inserted into a TensorFlow model or something like that. And Feather does support defining features as categoricals. There are a few other supported types like that too. Then the output type that is passed out into like the training or inference context is then, it doesn't reflect like categorical. It would just
Yeah, sure. That's
the lower level type to the to the machine learning platform construct. So we have this sort of high level and low level type paradigm within Feather, which I think is my preferred way to do it. I think that like it's useful to be able to talk at one level, right, about like what type of tensor is this thing, and then to have in the Swiss Army knife and in the definition APIs, the ability to have more convenient and semantic concepts to help people define their features that they want to define.
Anyone else want to comment on feature types and?
Yeah, I just wanted to add that it also opens up like help we can do or pain points we can take away from the data scientist. Then, because if you see that you have a categorical feature, there's usually a bunch of steps involved that you don't get around when using a categorical feature. So either you have to one-hot encode it or use some kind of label encoder. And maybe that's the next set of tooling that we can provide to propose those or automate those transformation functions essentially that are coming after the feature store.
The model-specific transformations.
Yeah, exactly. So yeah, maybe it can help in like selecting the categories which should be kept as features for my one-hot encoding, or yeah, some type of binning or those things.
Yeah.
Yeah.
Okay, we do see that a lot. Sorry.
So we're running out of time. So we've talked a bit about APIs, and I think we haven't had too many disagreements. Where are feature stores going from here? You got like going to be a quick answer. I'm sorry, it's going to be like 30 seconds. So this is open. You don't have to answer it, but please go in turn. Where do we go with feature stores from here?
My favorite is metadata. Connecting the downstream and the upstream through a common metadata, I think, is where we're going.
I think we're going to be moving towards features being generated in real time, and that's how you collect it, where you just either reprocess your entire, I guess, Kafka stream and then generate a feature based on kind of like Flink SQL on demand and reprocess everything. And that's how everything gets created versus the traditional old SQL way of aggregating things in the background, trying to replicate what happens in real time.
So the what we call the flywheel, where the data flows in and around and back in.
Mm-hmm.
Yeah, that's definitely a big thing. Making more of the Swiss Army knife tools work well in the real-time streaming setting. To rely too much on that analogy of a Swiss Army knife is a thing that I think about a lot for Feather. For like the long-term future, like what will we be talking about feature stores in 5 years, or how will these systems evolve, and like how do they relate to other parts in the ML stack? It's like or I don't know, what does the future hold? It's I don't know if that's exactly what you meant with the question, but there's like
that's good enough. Thanks, Xiaoyong.
Yeah, I feel my biggest sort of vision there is at least to get feature store as a concept more as a proven success to all the users, because we do have a nice group here, but it's still a small group compared with, let's say, data engineering, Spark, and all those kind of huge folks and the huge community there. So I think feature store as a new concept still have a long way to go, and getting more adopted and get the value proved to the folks outside of this community. That's probably the highest priority for me.
Moritz.
Yeah, I think we're moving more towards, or like we'll be getting closer with the serving side of things. So if we think of deriving features at real time, we need to be tightly integrated with the serving infrastructure. So where does the data come from with the request? Where does it go for feature engineering, and how does it get passed to the model ultimately, right? So the closer the two are together, the easier it will be to get to this future where all the features are computed on the fly, basically. And then also getting back the prediction and writing it back into the feature store or into some kind of other prediction store to be able to later on monitor the model and also the features.
Okay, thanks everyone.